Hello, I want to talk in this video about the formation of imines and enamines using an addition elimination mechanism of a primary or secondary amine to a ketone or an aldehyde. So I've got cyclohexanone up here on the board reacting with either methylamine or dimethylamine. Primary amine is going to give us an imine. So this is our primary amine going to form an imine, and our secondary amine going to form an enamine. I have the reversible equilibrium arrows up here just to remind us that these are reversible reactions. So depending on the conditions, we're going to favor either the ketone or the products. Right, and again, the thing to remember here is to favor products. And again, the products are the imine and the enamine. So to favor products, remove water, right? And again, you can see that water is here for both of the products. And again, according to Le Chatelier's principle, if you remove a product, that favors formation of more products. So that's how we're going to favor formation of the products. If we want to favor the reactant, right? And again, the reactant in this case is the ketone, so it's going to be the ketone or the aldehyde. You're just going to add water. So if you have an imine or an enamine, or remember a ketal or an acetal, and you want to go back to the ketone or aldehyde, just add acid and water and you're going to get back to the reactants, because again, you're adding more product, you add more product, that favors formation of the starting material. Okay, so let's go through what this mechanism looks like, and what I'm going to do is draw out the mechanism going from the ketone to either the imine or the enamine. The thing to remember is that if you want the mechanism to go from the enamine or imine back to the ketone, you're going to draw the exact same mechanism, just reversing the order of the steps, right? So it's going to look exactly the same. I'm going to go from ketone to imine. If you want to go back, you just go backwards in your mechanism, and it's all the same steps. Okay, so again, hopefully we're getting used to the fact that the first thing we're going to do is to protonate the carbonyl, right? So grab acid, and again, that's the first step in either of these, is we're going to protonate the carbonyl, right? And next thing we're going to do then is to add our weak nucleophile after we protonate the carbonyl. We can do that, right? So we're going to separate these two mechanisms. So we'll go with the secondary amine first. So add to the carbonyl. So there's our tetrahedral intermediate. Again, as we've seen several times, we're now going to do a proton transfer the proton from the nitrogen to the oxygen. Now we can remove water. Right? This is our step to eliminate water from the molecule. That's going to give us the iminium ion intermediate. And we need to get from that iminium ion intermediate to a neutral product. And again, there's a variety of ways that we can do this. When you get to iminium ion like this, where there's no NH bond, we can't do a proton transfer. We'll do that to get to the imine in just a minute. But when you get to this iminium ion formed from reaction with a secondary amine, you can't do that. So to get to a neutral product, you're going to have to remove another proton, right? And I think you can see which proton you have to remove if you draw the resonance structure. So the resonance structure is a carbocation, right? And the only difference between the enamine and that carbocation is a CH bond. And so to get from the iminium ion intermediate to an enamine, you just have to remove, deprotonate that iminium ion intermediate, right? And so this is just an acid-base reaction to get you to the enamine. Water is acting as the base, that carbocation is acting as the acid. And again, what does this do? It regenerates the acid catalyst, right? And this is, again, we can just write this here. This is going to regenerate the H3O plus catalyst, which again, you have to do so that your mechanism is complete, all right? So that final acid-base reaction regenerates the acid catalyst and generates the enamine. Now, if we go in the other direction, so let's react this with the primary amine. Right, we're going to get to a very similar tetrahedral intermediate. Proton transfer. And now we can remove water. That gives us our iminium-ion intermediate. Right? And again, remember, we have to go through that iminium-ion intermediate because it's addition and elimination of water for both of these, right? And forming the iminium is when we eliminate water, right? And now to get to the imine, this is the simpler of the mechanisms where we just do a deprotonation of the hydrogen on the nitrogen, right? So that allows us to regenerate our acid catalyst and generate the imine that we need as our product. Okay, so again, I hope that it's clear these mechanisms look virtually identical. The only difference is where do you pull the proton off in the final step when you get the neutral product and regenerate the acid catalyst. To form the enamine, you have to remove a CH bond, whereas to form the imine, you just have to break that NH bond. Okay, and again, we're going to use these all the time. Final point. Again, as I said previously, if you have to go backwards, just draw the steps in reverse. Okay, so if you're going from an imine to a ketone, you're going to do everything in reverse. You're going to protonate the imine first, right? Then you're going to add water to it, and then you're going to do a proton transfer, and so on, right? So I'm going to let you draw that out on your own as practice. Again, all of the intermediates are going to look the same. It's just that the curved arrows are going to go in the opposite direction, right? So it's a good thing for you to practice drawing those out. Again, same deal if you go reverse for the enamine one.